Lesson 4.4 is on linear functions. Well, linear, as we've talked much before, comes from line. We're going to talk about functions that can be represented as equations of lines. So, a function in which the graph of the solution forms a line is called a linear function. A linear function can be represented by an equation, a table, a set of ordered pairs, or a graph. So a lot of ways of representing it, and we're actually going to use all of them in a single problem. So let's take a look at this first example. Complete the function table, then graph the function. So instead of a function, they gave us this equation, y equals x plus 3. What I want you to know is that this is equivalent, I'm sorry, I'm not sure why that happened. This is equivalent, as in it's the same thing as saying f of x equals x plus 3. And that's the rule they have given us. We have our input, which is our x, our rule, and our output, which is y, just like from the previous lesson. Let's go ahead and start with that. Well, instead of x plus 3, we talked about how now it'll say negative 2 plus 3, and that equals 1. Instead of x plus 3, it's now 0 plus 3, which equals 3. Instead of x, it is now 1 plus 3, so 4. And then 2 plus 3, which is 5. Now that table is just like the previous lesson. We're going to take it a step further. We're actually combining together pretty much lessons 1, 2, and 3 into one complete idea. We're going to create ordered pairs. We have an x and we have a y. Therefore, we can put them together in the form of x comma y, or negative 2 comma 1. And then we have 0 and 3, so it's 0 comma 3. Then 1 comma 4 and 2 comma 5. Now we have our ordered pairs, we need to figure out, well, how to put that on the graph. Now, I noticed looking at this graph, there is some sort of printing issue. There's an equal sign and a plus sign. We're going to do our best to ignore them. But we have a grid that there are 1, 2, 3, 4, 5 spaces. So let's use that as our scale. Each of the axes will count by 1. And I'm not going to fill in the whole thing, just enough for us to understand what is happening. So let's go ahead and graph our first point. Negative 2 comma 1. Since our x is negative 2, we count left 2. And then our y is positive 1, so up 1 to get our first coordinate. And I wrote on there to show you where it's at, but for you, I would just say use your pencil, maybe, to dot your way over. But I'm just trying to put as few marks on this as possible outside of our answer. Next, it's 0 comma 3, so I start at the origin. If my first number is 0, that means I do not count left or right. I stay there. And a positive 3 means I count up and put a dot right here at 0 comma 3. We'll do that again for 1 comma 4. Positive 1 is my x, tells me to go to the right? And then +4 tells me to go up. 1, 2, 3, 4 to get a dot right there. Now, we're talking about linear functions. And so far, those 3 dots are in a straight line. That is our goal. We want our dots to be in a straight line. So we could almost make the guess. My next point in line would be right here. Well, let's confirm that. We had to go right 2 for the x being 2. Our y is 5, so 1, 2, 3, 4, 5 up. Perfect. That's exactly where we wanted it. So that's all you were asked to do, is to be able to go from the equation or function over to the graph. In fact, the next things we look at are going to ask you just to graph the function. It's going to be up to you to create your table to figure out what is your x, what is your y, and how to put it on the graph. All right, let's take a look at one of those. Starting up here at number 2, I'm going to move that one down out of the way. Number 2, need a couple things. Well, I could create a table where I have my x, I follow it with my rule of 3x plus 2, my y, and then my x comma y. I saw a lot of fabulous work where people got a separate sheet of paper, and so they could keep their work organized. They actually did all of their work on another sheet of paper, just filling in all these tables, and then just put the graph on their worksheet. They turned all those in together. It was beautiful. I would advise everyone to do that. Now, the numbers that go in the x column. In the previous problem, we only used 4. I am going to present to you now the 5 numbers I want us to get used to using every time we make a table for our functions. For the purposes of what we're going to cover, these are going to mainly be the 5 we use. There might be a few times we don't. We'll cover about that later. The x numbers we're going to use are -2, -1, 0, 1, and 2. If we use those 5 numbers each time, we're going to get our correct answers. So let's start with the first one of -2. We have 3x plus 2. That becomes 3 times -2 plus 2. Work that out on the side or in your calculators. 3 times -2 is -6. -6 plus 2 is -4. So I get the coordinate of -2, comma, -4. Now, there's a lot of different styles. You could complete the table first and then graph, or you could graph the point as you get it. I personally tend to complete all of the work before I go and do my graph, because the graph's the easy part, at least for me. Again, I'm not everybody. You guys might like to do it one at a time. So 3 times -1 is -3. -3 plus 2 is -1. So our second coordinate is -1, comma, -1. Next, 3x becomes 3 times 0 plus 2. 3 times 0 is 0. 0 plus 2 is 2. Therefore, we get the coordinate 0, comma, 2. Next, instead of 3 times x, it's 3 times 1 plus 2. 3 times 1 is 3. 3 plus 2 is 5. So 1, comma, 5. And finally, 3 times 2, the yellow's all right to read, plus 2. 3 times 2 is 6. 6 plus 2 is 8. So I get a coordinate of 2, comma 8. All right, so this is one of the advantages to weighting. There's a couple ways you could do this graph. We could go ahead, and the way I would do it is to count each space by 1. We're going to find that one of our numbers does not fit, but we should still be able to find our line. Our first coordinate of -2, -4, I would start at the origin, count left 2 and down 1, 2, 3, 4 to get my coordinate. -1, -1, I start at the origin, count left 1 and down 1, getting my second coordinate. Zero, comma 2 is I start at the origin. The 0 means I don't count left to right, but that 2 means I count up 2. And so far we're doing all right. If you notice, those are in line with each other. I'm just double checking some numbers. Awesome. 1, comma 5, start at the origin, count right 1 and up 5. And now we find that those are the only points we can actually fit here. This final point, this 2, comma 8, depending on your teacher, they may want you to shrink your graph or any number of other things. I'm going to say that it's okay. We have our graph of this function. We have our line. Now, if this was a better answer, I would have marked each coordinate with its location. And then make sure I draw my line through it. Remember, I have some rules when it comes to lines. It must go straight. Use some sort of straight edge to get your straight line. It goes off the charts and has arrows at the ends. Now, an even stronger thing here is we could actually name our graph. We could say that this is the graph of y equals 3x plus 2, and just kind of have something pointing to it. Sometimes you see word bubbles. But that's it. That is our line. Using, again, all the skills we've done up to this point, we're combining it into one idea. I'm going to do one more of these with you, and then I'm going to have one for you to try on your own. All right. Again, pause and go back and listen to any point. But let's go ahead and keep moving. Our next example is y equals 2 minus x. Again, I need to create my table with x, my rule, y, and x, comma, y. I should be a little more careful as I'm drawing my lines. But here are my x values: -2, -1, 0, 1, and 2. And I want to do this one with you purposely because I want you to make sure you're being careful with everything that you do. For starters, the very first one, when x is -2, we have 2 minus, notice that that minus didn't go away. X is -2, therefore it's a -2. 2 minus a -2. We have talked in detail about how when we have minus a negative, it really all becomes positive, making this 2 plus 2, which is 4. So negative 2 comma 4. Let's see that again. 2 minus, now this time x is negative 1, so 2 minus a negative 1. Minus a negative becomes plus. 2 plus 1 is 3. 1, -1 comma 3 is our coordinate. Now, we know that this will have worked if these 2 points are in fact in line with the others. So it's kind of a way of proving to you guys why this works. Next, we have 2 minus 0. Nice and simple. That comes out to 2. So 0 comma 2. 2 minus 1 is 1. So 1 comma 1. And lastly, 2 minus 2 is 0. So we have a coordinate at 2 comma 0. Let's go ahead and put these on the graph. I am again going to just use 1, 2, 3, 4, and 5. My scale is 1 to put these on the graph. Starting at the origin for negative 2 comma 4, I go left 2 and up 1, 2, 3, 4 to get a coordinate. So that is 2 comma 4. Sorry, negative 2 comma 4. Next, start at the origin. Negative 1 is left 1. Positive 3 is up 3. So I have the coordinate negative 1 comma 3. Start at the origin. 0 means I don't move left to right. 2 means I go up 2. So far, so good. We're all in a straight line. Start at the origin. Positive 1, positive 1. And finally, start at the origin, count right 2. And then my next number is 0, so I stay right here for 2 comma 0. I apologize that yellow was hard to read. From certain angles, it's pretty easy, but I'll try to use a different color as I move forward. From here, all I have to do is make my straight line. Notice that I still took it off the grid. Make my arrows. And that's my line. And again, another strong thing to do would be to say that this is y equals 2 minus x. But again, that's not absolutely necessary. Your teacher may say so. I'm worried about, can you get this on the graph? All right, so here's your example. I would like for you to do this example on your own. I will help you in showing you what the table looks like, but I would like you to take this equation and use the table to find all of your coordinates for this graph. Pause the video, do the work, and when you start the video back up, all the answers will be right in front of you to see how you did. So pause the video in 3, 2, 1, pause. All right, welcome back. Again, check your chart against mine and see how the graph works out. Just again, to have another visual example. Go back and watch any of the examples prior to this one to double check how you're doing. And when we get closer to any assessments, this is going to be a crucial video to come back to because it covers pretty much everything we've done up to this point. Now for one last thing to talk about. This is kind of a aside, honestly, when it comes to this work, but it's good to start hearing these kind of terms. We're talking about whether data is continuous or discrete. What continuous means is really, can our answers have all real numbers? And what that means is, can it be 1, and then 1.1, and 1.2, and 1.3, and anything in between? So I'm talking any possible number, such as the weights of something, or the sizes of something. And then we have discrete, where discrete is there's a very specific pattern. So it's not every possible number, but it could be like 1, 2, 3, 4. So it skips everything in between and just counts up by 1 each time.